Up to this point, we've only seen how to take the determinant of a matrix by expanding along the first row. But it turns out if you know what you're doing, you could expand along any row or column. And by carefully choosing which row or column you expand along, you can make things a lot easier on yourself. Okay, so let me prove it to you. Let's calculate the determinant of A. Let's start by expanding along the first row as usual. Okay, I'm going to do this quickly. So negative 2 times the determinant of what's left. Now what's left is a 2 by 2, so I'm going to get negative 2 times 0 plus 0. So negative 2 times 0. And then I have 2, next element in the first row, and then take the 2 by 2 of what's left. I get negative 6 minus negative 2. Negative 6 minus negative 2 is negative 4. So I get 2 times negative 4. And then negative 1 times 0 minus 0. That's negative 1 times 0. Alternate signs, positive, negative, positive. Okay. Notice I keep the sign with the number that's already there. So this was a negative 2. So I imagine putting a positive in front, not changing the sign on this. Okay. This was a positive 2, but since it's the second entry in the first row, I put a negative in front of the cofactor. All right. And so this gives me 8. Okay. Let's see what happens if instead I try expanding along the first column. So this was along the first row. Now let's see what happens if I go along the first column. So I start off the same. Negative 2 times 0 minus 0. Next entry in the first column, I'm going to get 2 times negative 6 minus 0. So 2 times negative 6. Last entry in the first column, I'm going to get negative 2 times 2 minus 0. So that's 2. Okay, alternate signs, plus, minus, plus. I'm going to get negative 2 times 0 is 0. Minus 2 times negative 6 is a positive 12. Plus negative 2 times 2 is a negative 4. I get 8. It's exactly the same thing. Okay. Now, it works for any row or column. So let's try one more. Let's go along the second column. Okay, so if I go along the second column, I get 2 times 2 times negative 3, that's negative 6, minus 2. So negative 6 minus negative 2 is going to be negative 4. So I have 2 times negative 4. Okay, next entry, I have 0, and then I cancel out the row and column. What I'd have left would be 6 minus 2. But do I really care? I'm going to have 0 times something. Do I really care what the something is? Not so much, right? It's just going to be 0. Okay, so zeros are nice to expand along. Next 0, I'm going to have the same issue. Cancel out the row and column. Technically, we would multiply that 0 by the determinant of what's left. But whatever this determinant is, it's going to be multiplied by a 0. So I'm going to get a 0 again. Okay, so what? Plus, minus, plus, and I get -8. That's not quite the same, right? We're off by a sign. So it turns out you have to keep track of what row and column you're in, all right? When expanding along a matrix, the sign that goes in front of your cofactor is determined by which position you're in. So you always start in the first row, first column. That's a positive, okay? But then you alternate after that. Positive, negative, positive, negative, positive, negative, and so on. Okay? However long you go. Same thing with rows. Positive, negative, I'm sorry, with columns. Positive, negative, and so on. And then each row after that. So you kind of have this checkerboard pattern of positives and negatives. Okay? So in our case, for our determinant, we actually got the signs wrong here because this is along the second column. Okay, when we expand along the second column, we think of this as a negative, this is a positive, this is a negative. Those are the signs that would go in front, right? Because we always start with a positive in that first entry, first row, first column. The second entry here is a negative, and then as we go down, negative, positive, negative. So as we expand along those elements, we have negative, negative, positive, negative. And doing it that way, then we will agree. We get -2 times -4 is a +8, and now it checks out. Okay? So when calculating the determinant, you could expand along any row or column. You just have to be careful with the signs. All right? By the way, which one of these felt easiest? Probably this last one, right? That second column, once we got the sign thing sorted out, it was real easy because 2 of them, we didn't even have to think about determinants, right? As soon as we knew we were finding the cofactor with a 0 in front, I don't care what the determinant is of what's left over. 0 times anything is 0. So by choosing a row or column that is easier, sometimes we can make finding the determinant easier. In particular, it's real nice to have a row or column with lots of zeros in it because it makes it a lot easier to find the determinant.